Okay, hello everyone. In this video, I would like to share with you the answer key of our CA questions. Okay, let's check it out. And also, I will show you here which or why some of you get this wrong. Okay, and most of you scored very well. Yes. So, in the first question, how many neutrons are in a nucleus of a nuclide? 37, 17. 17 means the amount of proton, and 37 is the combination of proton and also neutron, right? So that means the amount of neutron is the 37 uh, minus 17. So there are 20 neutrons. Okay. In question B, the nucleus contains proton. This is a neutral atom, consists of electron orbiting nucleus. Now the question is, which one correct? Since the keyword here is a neutral atom, so take a look at this. The number of electron is equal to the number of protons. Okay, negative charge is equal to positive charge. That is for sure and must be correct. In question 3, diagram represent an experiment that provided evidence for the nuclear atom. Okay, as we see here, we do not shoot beta particle to the gold nucleus. Okay, the previous scientist did not shoot beta particle, instead alpha particle, a positive charge. And we know that the gold nucleus is a positive charge. So the one that makes sense the most is C, because alpha particle did not attracted to the gold nucleus. Instead, it is repelled by the gold nucleus. So it's supposed to be C. In number 4, this is considered correct for everyone because the nuclides that isotope of the same elements uh, same elements have the same character depend on how much proton they have. So if we see here, we need to find the element that have the same number of proton. The proton number of nuclide 1 is 17, proton number of nuclide 2 is 17. So yes, the nuclide with 17 is the one that is correct. So, but there's no correct answer here. So it's supposed to be nuclide with uh, atom number of 17. Yeah. In question 5, we have particles and the conclusion after the experiment by the scientists about the structure of matter. So the particle that were used is alpha particles. This shows that instead of this, matter is made of atoms. There is something more specific. It says that atoms have a very small nucleus. This is the conclusion from shooting an alpha particles. Guys, look at this picture. An atom consists of the nucleus and also the electron around it. But when the alpha particle deflected, that shows the nucleus, that shows the center, the nucleus is very dense and positive charge, positively charged. Okay, so the answer is beta. Sorry, alpha particle. An atom have a very small nucleus. In question number 6, you need to be careful since the nucleon number of 7 and a proton number of 3. That means since the proton number of 3, then the only possible here is C. Why? Instead of D, we can see that the proton number is 3. That means the electron number is supposed to be 3 also, not this, not like D. It has 1, 2, 3, 4, 5, 6, 7 electron. Okay. Question 7. Radioactive nucleus emits beta particle. Beta particle have a negative 1 charge. So when it emit negative 1 charge, okay, but we want the amount of number remains the same. So that means If we give out negative 1, at the same time, we need to give out a positive 1. Where's the positive 1? Inside the nucleus. So that's why the number increased by 1. B, sorry, 9, which statement about neutral atom, okay? Now, in this case, this is very clear that the proton number is 88, and if we reduce 226 by 88, it's about 144, yeah, and that shows that the amount of neutrons is 140 something, is much more than a proton. So 9, it has more neutron than protons. Question number 10 is the same thing as question number 7. Since it emits beta particle, the amount of particle inside the nucleons increased by 1 positive, so 239. Number 11, to reduce the risk of people using radioactive material, then keeping in low temperature does not affect, doesn't give any effect. And also same with this question number 12. Okay. In question number 13, the product of alpha emission. Alpha contains a positive charge. So if positive charge came out from the nucleus, then the amount of positive charge inside the nucleus will be different. That means it will create different element. The nucleus will become a different element. Okay, while in beta emission, same thing, because previously we learned that the proton number of uh, atom increased by 1 if it emits beta particle. Then also for beta particle, a nucleus of different element will be created. So 13A. In here, in question 14, this is very clear. In this decay, we can see that the top number, the amount of particle inside the nucleus is the same, but the proton number is different. So that means um, we need to add something in here in which the bottom number should be the same as in the left. Yeah, in the left, this is 91 and this is 92. To make it the same, the bottom number need to be negative 1, right? While the top number need to be remain 0. So something that have top number of 0 and bottom number of negative 1 is beta particle. Okay, so that should be a beta particle. This is it, D. All right. Now 14. Most of you get this correctly, 100 milligram, and 16. Be careful. This is 4,000 after 2 days. 2,000 after another 2 days, which is means 4 days, become 1,000. After 6 days, another 2 days become 500. Another 2 days means 8 days becomes 500 divided by 1, 250. Okay, C. For 17, the half-life of the source is easy to find. 800 divided by 2 is 400. It happens after 20 minutes. Let's check. After another 20 minutes, yes, the number of emission becomes half. So that means the half-life is 20, correct? Number 18, this is about the ionizing effect. Of course, alpha is greater than beta, so the possible answer is A or B, but the penetrating ability for alpha is less. So that means the correct answer is B. For this answer, I don't know why, there's a technical problem when it's printed. Uh, uh, it is printed like enlarge or something, it's zoom in. Okay, let's see the time for a moment. Do we have, okay, we have about 5 minutes. Now let's continue. So, oh yeah, here. This is supposed to be, instead of XYZ, is supposed to be A, B, and C. We can see The least penetrating supposed to be alpha, the most penetrating supposed to be gamma. So that means this is beta, alpha, gamma. Okay, beta, alpha, gamma. The answer is B. Number 20, why does not fall to zero the reading of this detector when the aluminum sheet is increased? That because in our logic, supposed to be the beta particle already stopped, but there's always some background radiation that we cannot avoid. Okay, this one be very careful. If the radiation is too close to the nucleus, it will be deflected downward. Here in the middle of the two nucleus, it can just move straight, but this one hit directly. Okay, so it will be bounced back. State the result of the experiment that letter B. State the result of the experiment that shows an atom consists of a very tiny charged core. You can answer by two things. You can say that most of the alpha particle passes through. If it passes through, then it consists of a very tiny core. Okay, and also some alpha particle bounce back. That means bounce back or deflected, containing almost all the mass of the atom. Uh, that means you can say that the uh, nucleus repel alpha or bounce alpha back. State the sign of the core of the charge of a core is supposed to be positive, and what occupies the space between the charged core is empty, nothing, a vacuum. For alpha particle, the amount of proton is 2. The amount of neutron, take a look. The contain inside the nucleus, the number is 4, and the number of proton is 2. That means 4 is combination of 2 proton and 2 something. That 2 something is the amount of neutron. So the neutron is also 2. Here, we don't not need to discuss this, but you need to be very careful on this. Alpha particle A is traveling along line which does not pass very close to a gold nucleus. If it's not pass very close, it can just go straight. While B traveling along a line which is passes close, it will be deflected downward or upward. And C traveling directly towards the gold nucleus, it will be bounced back. Okay. Um, Explain why alpha particle and gold nucleus repel each other. Of course, they have the same charge. And state two conclusion about gold atom. You can choose among the three. While white space between the nucleus contains positive charge, or you can say nucleus is very dense. Now, here in question number 23, let's check the time available for us. Okay, it's about 2 minutes. Let's make it fast. The count rate after, okay, this was crop. The question is supposed to be like this. Okay, we will skip this one and we will just go to question 24. Here, if you want to add some radioactive inside here, it is better for gamma. Uh, Remember that beta has also limitation in passing through a lot of material. So gamma is the best to penetrate the ground and detected by the technician. Okay. Okay. About this, remember alpha is a helium nuclide. Beta is similar to electrons. Okay. While the other number you can check. But in letter C, most of the mistakes is on how you calculate how many more hours instead of how many hours, but how many more hours. Okay. So it's supposed to be 24 hours. Okay. Be prepared for remedial if your mark is below KKM. See you soon.